You are welcome to today's lesson. Today we are beginning our discussion on rigid motion 2. And our subtopic for discussion is rotation through 90 degrees anticlockwise. And this is the part 1 of the lesson. Now let's look at our objectives for this lesson. By the end of the lesson, you should be able to 1. Rotate object through 90 degrees anticlockwise. You should be able to rotate object through 180 degrees anticlockwise. Also, you should be able to rotate objects through 270 degrees anticlockwise. And lastly, you should be able to rotate object about a point. Now, what is rotation? Rotation is a transformation in a plane or a surface which describes the movement of a rigid body around a fixed point. Don't worry if you don't understand certain terms. Rotation is done in the clockwise and anticlockwise direction about a point. This is an example of a rotation, that is the movement of an object or a plane figure around a fixed point. This kind of rotation is called clockwise rotation because they are moving forward. Now, when they start moving backwards, this is what we call the anticlockwise rotation. Now, let's take note. Rotation in the clockwise direction through an angle about a point is the negative of a rotation in the anticlockwise direction through the same angle about the same point. What that implies is that if I rotate an object in the clockwise direction, its opposite is what we are calling the anticlockwise direction. So when I move in the opposite direction or in a negative direction, then it means I am moving in the anticlockwise direction. Now let's talk about the x and y plane, which is also referred to as the Cartesian plane. We will need this concept as far as rotation is concerned. Now, what I have here is my vertical line representing the y-axis, and this is also my horizontal line representing the x-axis. On the right side of the x-axis is colored green, and that represents the positive side of the x-axis. On the left side, colored red represents the negative side of the x-axis. In the same way, the upper side of the y-axis, which is colored green, also represents the positive side, and the lower side, colored red, represents the negative side of the y-axis. Between the green lines is what we call the first quadrant. So the region between the positive x-axis and the positive y-axis is what we call the first quadrant. What follows is what we call the second quadrant. That is the region or space between the negative x-axis and the positive y-axis. That is the red and the green. The next side represents the third quadrant. That is the space between the negative x-axis and the negative y-axis. That is the red region. And the last quadrant is the fourth quadrant, which is the space between the positive x-axis and the negative y-axis. And in that region, we can see the color green and red. In each quadrant, there is an angle. So the first quadrant measures an angle of 90 degrees. The second quadrant also measures the same angle, 90 degrees. The third quadrant is the same, and the fourth quadrant as well. So in each quadrant, there is an angle of 90 degrees. How do we perform rotation 90 degrees anticlockwise? Anticlockwise means we are moving backwards. Anytime you are performing rotation always starts from the first quadrant. That is where the lines have been drawn in green. Since we are moving backward, it means that the y must be moved first, followed by the x. So remember I said rotation starts with the first quadrant. But since we are moving backwards, the y moves first, followed by the x. Let's observe how rotation 90 degrees anticlockwise is performed. Remember, anytime you are performing rotation, it starts within the first quadrant. Since we are moving back, the y moves first, then the x follows. And right now we've covered an angle of 90 degrees. This is what we mean by rotation 90 degrees anticlockwise. After performing the movement, if you observe on the x-axis, you realize that we have y. And this y is appearing on the negative side of the x-axis. On the y-axis, we have x, that is after performing the rotation. And this x appears on the positive side of the y-axis. This implies that anytime I have an object or a point xy, and I'm rotating it through the angle 90 degrees anticlockwise about the origin, the x-axis will have y, but this y appears on the negative side of the x-axis. That is why we have negative y. And on the y-axis, after performing the rotation, we can see that we have x on the y-axis, and this x appears on the positive side of the y-axis. That is why the x is positive. In other words, anytime you are performing rotation 90 degrees anticlockwise, the x-coordinate of the object goes down. Then the y-coordinate moves up. By this time around, all you are going to do is to negate the y to produce the image. And so this can also be written as a point, which is xy mapping to negative y, x. Now let's look at an example. In this example, you are to draw the triangle ABC with vertices A 2, 4, B 3, 6, and C 6, 6. Also, you are to draw the image triangle A1, B1, C1 of triangle ABC under a rotation through 90 degrees anticlockwise about the origin. Then lastly, you are to indicate the coordinates of the triangle A1, B1, C1. Now let's look at our solution. Remember we said anytime you are rotating an object point through 90 degrees anticlockwise, what happens is that the x-coordinate goes down, then the y-coordinate moves up, and we negate the y to produce the image point. So remember the first point given to us in the question was point A, 2, 4. And so to get the image point A1, we move the x-coordinate down, that is the value 2, down, and the y-coordinate, which is 4, moves up. Then we negate the y to become negative 4. Also, the point B given to us was 3, 6. So in the same way, the x-coordinate, which is 3, moves down. Then the y-coordinate, which is 6, also moves up. Then we negate the y to become negative 6. So the image point becomes B1, negative 6, 3. Then the last point, which is C, 6, 6. In the same way, the x-coordinate of the object point will move down. Then the y-coordinate of the object point moves up. Then we negate the y. So that is why we have negative 6, 6. Now we can plot our solution on the graph. And so as usual, to do that, we will need the x and the y-axis. I will need the positive and the negative side of my y-axis. I will need the positive and the negative side of the x-axis. Remember the points given to us to plot were A 2, 4, B 3, 6, and C 6, 6. So quickly we plot them. So the point A is 2, 4, B, which is 3, 6, and C, 6, 6. So quickly we join the points together to form the triangle ABC. Remember, we were told to reflect the triangle ABC under the rotation 90 degrees anticlockwise, and the image points produced were A1, which was negative 4, 2, B1, which was negative 6, 3, and C1, which was negative 6, 6. So quickly we join the points together to produce the image triangle A1, B1, C1. Let's take note that anytime you are performing rotation 90 degrees anticlockwise about the origin, it produces the same result as rotation 270 degrees clockwise about the origin. I'm going to explain this concept in detail in the next video. Stay tuned. Don't forget to also subscribe and like.